If C is the scalar, then the length of C times U is the length of U times the absolute value of the scalar. And we'll prove this by definition. Well, first, what is CU? Well, it's C times U. U1, U2, down to U sub n, which is CU1, CU2, down to CUN. Okay, so the length of CU, by def, is the length of CU. CU1, CU2, down to CUN, which is equal to CU1 quantity squared plus CU2 quantity squared all the way down to CUN quantity squared. But that equals square root of this. That equals to C squared U1 squared plus C squared U2 squared all the way down to C squared U sub n squared square root. And underneath that square root sign, I can factor out C squared. And I get C squared times U1 squared plus U2 squared all the way down to U sub n squared. And the square root of a product is a product of the square roots, as long as none of these are negative. Well, C squared is, as long as they're both not negative. C squared is not negative, and U1 squared, U2 squared, none of those are negative, so their sum won't be negative. Okay. Now the square root of C squared is the absolute value of C. And it turns out that the square root of that is the length of U. There's the proof. Nice quick proof. Shouldn't take but a couple of minutes for you to do it as well. If you like videos like this, subscribe to my channel. Tell your friends and family, teachers, and classmates about the channel. Leave comments. If you want to see me prove a particular theorem, leave that in the comment section. Most of all, watch and learn.